Hello, everybody. This is Aaron Schwartz, one of the secondary math specialists at Montgomery County Public Schools. In this screencast, we're going to be looking at standard form of a linear equation. This screencast is called sum of one, none of the other, which is something we'll dive into later. In Unit 2, Topic 2, students learn to build equations recursively and explicitly as descriptions of recurring patterns. The key ideas include that equations can be used as a succinct description of a pattern. Standard form expresses the constant sum of two varying quantities, ax plus by equals a constant c. One of the helpful skills that students have learned in previous courses is that equations are solved by inverting the operations and the order of these operations. They've engaged in this learning in Math 7, IM, Math 8, and reviewed it in Unit 1, Topic 1 of Algebra 1. Standard form is best explored in the context of a scenario. So we're looking at a scenario that I call half-baked ideas. At Alexis's bakery, she's preparing batter for baking. The amount of flour is limited. Alexis cannot exceed 60 portions of flour. Each batch of cupcakes requires 4 portions of flour, and each batch of brownies requires 3 portions of flour. Knowing that she should try to have both, she needs to find combinations of brownies and cupcakes that do not exceed the flour constraint. This scenario is actually presented in terms of a linear inequality. We're just going to focus on what we call the boundary line for this video. So let's write the equation. We know that we need 4 portions of flour for the number of cupcakes that she'll make and 3 portions of flour for the number of brownies. So the number of cupcakes times the amount of flour increased by the number of brownies times the amount of flour has to equal the 60 portions of flour that she has. Or in terms of an equation, 4x plus 3y equals 60. So this is why we're going to talk about this video of sum of one, none of the other. We're going to start talking about scenarios where we have all cupcakes and no brownies. And then we're going to reverse it to look at no cupcakes and all brownies. In other words, sum of one, none of the other. This allows us to reveal the x and y intercepts when we want to graph the equation. 4x plus 3y equals 60, but we're looking for no brownies in this case. So just 4x equals 60, so x equals 15. Now let's reverse the situation and let's look for none of the cupcakes and all of the brownies. Again, we start with 4x plus 3y equals 60, but we have no cupcakes. So we're just going to say 3y equals 60, y equals 20. This means that when we have all cupcakes and no brownies, we're going to have 15 batches of cupcakes. When we have no cupcakes and all brownies, we'll have 20 batches of brownies. And we can use this to graph. I've created a graph where my x-axis is cupcakes and my y-axis is brownies. I've graphed my intercepts, or the places where I have sum of one and none of the other. One of the popular skills that we ask students to engage in is converting to slope-intercept form. There's lots of reasons to do this. It's become a common practice to convert to slope-intercept form before graphing. But the reason that it's become a common practice is a little bit surprising. It's a practice that serves the needs of the TI-81, 82, 83, and 84 calculators, the common calculators used in classrooms, and other graphing calculators such as the Casios. All of these are technology that are limited to graphing functions in the form y equals, when actually we don't need to convert to graph. By determining the intercepts, we'll have our line. So there's no reason to convert when graphing by hand or with modern software such as GeoGebra or Desmos, but it's still useful in certain situations. And so it's still a valuable skill to have students convert from standard form to slope-intercept form. So let's look at some ways of doing this. We're going to start with algebraic manipulation. 4x plus 3y equals 60. Typically, we subtract 4x from both sides. 3y equals negative 4x plus 60. We're going to divide by that coefficient of the y. And we'll come up with y equals negative 4/3 x plus 20. This is absolutely correct and an absolutely valid process. The problem is that there are a lot of steps here where simple errors can create an incorrect line or an incorrect equation for that line. So how do we use patterns, and how do we use the understanding of those patterns to skip all this work? Well, we're still going to have to do some of the work. But we're going to try an alternate approach. I'm going to start with my equation, and I'm actually going to make a table because I want students to notice certain things. And the first thing that we're going to do with our table is go right back to sum of one and none of the other. We're going to determine our intercepts, and those are the only values we'll populate on the table. When we have no cupcakes, we had 20 batches of brownies. When we had no brownies, we had 15 batches of cupcakes. At this point, because I have a table with two values, I can actually determine the slope. I'll look at my rate of change for x and my rate of change for y. As my cupcakes increase by 15, the number of brownies that I can make decreases by 20. So as a fraction, negative 20 over 15 simplifies to negative 4 over 3. I now have my slope, and I have my y-intercept since I calculated it on the table. Negative 4/3 x plus 20. There's an interesting pattern here that I would ask students to observe. Our slope is very closely associated with the coefficients of x and y in our original standard form equation. So now the question is, how do we use this information to avoid all of the algebraic manipulation? Let's look at another example. We're going to look at some of those patterns to expedite the process. Here's a new equation. 5x plus 4y equals 40. Again, we're going to start by finding sum of one and none of the other. None of the x's means that the value of y must be 10. 4y equals 40. Divide by 4, we get 10. We can find sum of one and none of the other for y. 5x equals 40, so x has to equal 8. Let's find our rate of change. As we increase x in value by 8, we decrease y in value by 10. Our slope is negative 10 over 8, which simplifies to negative 5 over 4. And notice that it has a pattern that's built in and associated with the coefficients of x and y. So there's a couple generalizations we can make. For any standard form equation, ax plus by equals c, the slope is just negative a over b. And the y-intercept is just going to be c, the constant, divided by the coefficient b for y. I hope that this video helps teachers create classrooms where students explore the math, observe patterns, and develop conceptual understanding. If you have questions, comments, or have a video idea, please email me at the address below. Thank you very much, and I hope everybody enjoyed this presentation.